All right, so here we have a city council consists of 6 Democrats and 4 Republicans. If a committee of 3 people is selected, find the probability of selecting 1 Democrat and 2 Republicans. All right. Well, if we remember, that's going to be 10 total, and we're choosing 3. So our total number, we did that before, if we remember, right? That was 120 total ways. So that's going to be our denominator. And the number of ways of selecting 1 Democrat out of 6, that's going to be 6C1. And we have 4 Republicans, and we're choosing 2. So we're going to have 4C2. That's going to be our other one. So our numerator then will be math 3, and we're going to have 6 choose 1, and then times math 3, and we'll have 4 choose 2, and we get 36. So now we have 36 divided by 120, and if we reduce that, we get 3/10. So this was 36, and then the probability of that event occurring is 36 over 120, which we reduce to 3/10. Okay, so again, depends on how the problem is on what you're going to get here. So the next one, we're back to poker hands. So now we have to remember how many cards there are, how many of each suit, and everything else. So we're going to have a 5-card poker hand and find the total number of possible 5-card poker hands. Well, this looks like we're going to step through this one, and it's going to work us through. So there's 52 cards, and we're choosing 5 of them. So that will give us part A. Part B, a diamond flush is a 5-card hand consisting of all diamonds. Find the number of possible diamond flushes. Well, how many diamond cards are there? Well, remember, there's 4 suits. Each suit has 13 cards, and so there's going to be 13 diamonds. So we have 13, and we're choosing 5 of those. So that's going to be our numerator. This is going to be our denominator. That's going to be our numerator. And so C then is going to be this divided by this, and this time we can do it as a decimal as well as the other way, and kind of show you what it looks like. All right, so we had math 352. We're choosing 5 of them, and so we have 2, 5, 9, 8, 9, 6, 0. Okay, and now we're going to do math 3, and now we're choosing out of the 13 diamonds, we're choosing 5 of them. So that's going to be our numerator. All right, and so can we divide that by 3? Yeah, we can. Can we divide the 2, 5, 9, 8, 9, 6, 0 divided by 3? And we can. So the 429 over 8, 6, 6, 3, 2, 0, 9, 10, 11, 15. So can we divide it by 3 again? Nope. All right, so I think that's about as far as we can get. So we end up with, on that one, we get the 429 over the 866,320, and that's as far as we can go. Oh, and we were going to divide those out. So we take the 429 divided by 866,320. So we kind of have a decimal as well. And as you can see, this isn't very nice because we have that 3 zeros in front of that. So let's write everything down we have now. So the first one we said was 2, 5, 9, 8, 9, 6, 0. Here we had 1, 2, 8, 7. So then that was 1, 2, 8, 7 over 2, 5, 9, 8, 9, 6, 0. And as a decimal, we got 0.000495. But when we reduced it, we had 429 over, and then we had 866,320, if I remember right. 866,320. Yep. All right. So either way is going to be kind of our answer. So if they wanted a decimal to that many places or 3 significant figures, or as the fraction and reduced form, and I think that's as far as we can reduce that one. All right, so that's that example. Let's stop there, and we'll come back for some more.